Welcome to Scalecraft. Before we talk about Anycast, I have a simple question. Suppose I want to send a package. Who would receive it? Now there are four possible answers, and surprisingly, the internet supports all of them. So let's talk about it. First is Unicast, one sender and one receiver. Exactly like sending a package to your friend, one address and one destination. This is how most internet communication works. Your browser talking to Amazon or your phone calling Google server. One-to-one communication. Next is broadcast. Now suppose instead of sending a package, you stand in the middle of room and shout, free pizza. Everyone hears it, right? Whether they want it to or not. Now that's broadcast. One sender, everyone receives it. Now, broadcast is useful inside local networks. But imagine broadcasting it to the entire internet. It will create a compute chaos. That's why routers don't forward broadcast traffic across the internet. Next, we have multicast. Now, suppose you are running a newsletter, only people who subscribed should receive today's email, right? Everyone else should be ignored. Now that's multicast, one sender and many interested receivers. It's commonly used for like TV, live stock market feeds, video conferencing, and live sports streaming. And finally, we have Anycast. Now here is the interesting one. Suppose Starbucks has 500 stores. You don't care which one you visit, right? You simply want the nearest one. That's exactly what Anycast does. One IP address exists at hundreds of locations, and the internet automatically routes you to whichever is the closest. Today, we are going to understand exactly how this magic works. So let's continue our Amazon story from the last video. Rahul lives in Delhi. He opens Amazon.com. The first thing his computer needs to know it, what is Amazon's IP address. So his laptop sends a DNS request. Now suppose Amazon's DNS server exists only in New York. That tiny DNS request has to travel Delhi to Europe, then to Atlantic Ocean, and then finally to New York. Only then does Rahul know get the IP address. Now that's a lot of unnecessary travel just to ask a simple question. So can we do better? Absolutely. Enter Anycast. Instead of having one DNS server, suppose Cloudflare places 300 DNS servers across the entire world. Delhi, Mumbai, Singapore, London, New York, Sydney, everywhere. Now, here is the interesting part. Every single one of these servers advertise the exact same address. Yes, one IP. Hundreds of physical servers. Then comes the obvious question. When Rahul sends a request to 1.1.1.1, which server actually receives it? Right? There are a lot of competing servers. This is where the internet itself becomes intelligent. BGP makes the decision. BGP means Gateway Protocol. Rahul does not choose the server. DNS does not choose it. Cloudflare does not choose it. Instead, the routers that make up the internet decide. They use a protocol called BGP. Think of BGP as Google Maps for the internet. Every router constantly exchanges information about available routes. Each Cloudflare data center is called Point of Presence or POP. POP announces, hey Internet, I can serve traffic for IP address of 1.1.1. Now, since every POP announces the same IP, the Internet automatically picks the path with the fewest network hops. So, Rahul in Delhi reaches the Delhi or Mumbai POP. It will not go to like Singapore or New York POP. Now, someone in Paris reaches London, someone in California reaches Los Angeles. Same IP, different servers, automatically. No DNS tricks, no application logic, and no load balancer. The internet itself routes users to the nearest location. Now, that is the magic of Anycast. Now, how is this different from load balancing architecture? At the first glance, Anycast sounds similar to load balancer, right? but they work at different completely layers. A load balancer receives the request first and then decide which request should go to the which backend server. The request never reaches a central machine. The internet routes it directly. In case of Anycast, internet routes it directly to the nearest data center before your application even sees it. Think of it this way. Load balancer is a receptionist deciding which employee should help you. Anycast is like Google Maps choosing which office building you should visit. Completely different problems. What happens if a data center fails? Suppose the Mumbai POP crashes. Does Rahul need to change DNS? Wait for cache expiry? Start his browser? No, nothing. The Mumbai route simply stop announcing that IP through BGP, and within seconds, the internet routers discover a new best path. Rahul is automatically redirected to closest POP, perhaps Singapore. No manual intervention is needed, no DNS, TTL caching, no failover steps. The internet heals itself. Now, real world applications, let's talk about them. So let so where actually Anycast is used in real world. So we will talk about different use cases. First is like DNS. Cloudflare's famous DNS service sits at this particular IP. It is available from more than 300 locations worldwide. Every user connects to the nearest DNS server, making DNS lookups incredibly fast. Google DNS, which is like 4 digits of 8, works the same way. Next, we also have CDN Edge Networks. Now, suppose Rahul opens Amazon before loading products. His browser first download images, CSS, JavaScript, and all those things, right? So instead of patching all of this from one country, sends him to the nearest CDN Edge server. The result, lower latency, faster page loads, happy users. But here's where Anycast becomes incredibly powerful. Suppose an attacker launches a massive attack against the IP address of Cloudflare. Now, without Anycast, all traffic hits one data center, and eventually the data center becomes overland. Now, with Anycast, the attack is automatically spread across POPs around the world. They act like the army. So instead of one server receiving 1 billion requests, right? Now 300 servers each receive some fraction. No single location gets overwhelmed. And that's why companies like Cloudflare use Anycast as one of their strongest defense against the DDoS attacks. So, where does DNS fit in all of this? There's one thing many engineers get confused about. Now, if Anycast exists, why do we even need DNS? So, here's the difference. DNS and Anycast solve very different problems. DNS, what it do is, it converts Amazon.com into an IP address. Now that's all. Now suppose DNS returns some 104 something of address. Now that IP is not located in one place. It is actually advertised from hundreds of locations using Anycast. So DNS answers what IP should I use, and Anycast answers which physical server should handle this IP. Together they make modern internet routing possible. But there is one limitation of Anycast. Anycast works beautifully until you introduce long-lived TCP connections. Now let's see why. Rahul starts downloading a huge file. Okay. Now his TCP connection is established with the Mumbai POP. Okay. But halfway through the download, the internet discovers a slightly better route. Now Rahul's package suddenly arrived at Singapore POP instead, right? But Singapore has never seen this TCP connection before, so it has no session data. So from its perspective, these packages don't belong to any existing connection. The download will break. And this is why Anycast is perfect for DNS, UDP, or short HTTP requests, but much more challenging for long-lived TCP connections like SSH or large downloads. So modern CNS solve this using techniques like session affinity and intelligent routing. So overall, if we talk about like Anycast helps to allow multiple data centers around the world to advertise the same IP address using BGP. Internet routers automatically send users to the nearest point of presence called POP, which basically reduces latency and improves availability, and it helps to provide protection from DDoS. And that's why companies like Cloudflare, Google, AWS, they heavily rely on Anycast to power the modern internet today. So we learned how one IP address can exist on hundreds of servers simultaneously. In the next video, we will look at another networking concept. And if you're enjoying the session design series, subscribe to my channel. Don't miss the next lesson. I'll see you in the next video.